This is a second review doing the even problems. So 66, I believe this is, mean, median, and mode for each set of data. The mean, take the, let's see, there's 1, 2, 3, 4. There's 8 numbers, add them up, divide by 8. There's the mean. So the mean is the same thing as the average. To get the mode and the median, we need to put the numbers in order. In ascending or descending, doesn't matter. So when you do that, you get 22, 24, 30, 30, 33, 38, 41, 41. Now, there's 8 numbers. The median is the number that's in the middle in terms of sequential order. 1, 2, 3, 4, 5, 6, 7, 8. So there's no number in the middle because the number of numbers is even. So we take the 2 middle numbers and we add them together and we average them. And that gives us the median. And so the median is 30 plus 33 divided by 2, 31.5. Now the mode is simply whichever numbers occur the most. Now, if each number only occurred once, you wouldn't have a mode. You wouldn't say I had 8 modes or whatever. But since 30 occurs twice and 41 occurs twice, we'll say that we have modes of 30 and 41. Now, 68, same thing. Okay, I'm sorry, 68 asks you, Kevin's scores on the first 4 science tests are 88, 92, 82, and 94. Which score must he earn on the 5th test so that the mean will be 90? Okay, so there'll be 5 tests altogether, including the unknown score, 88 plus 92 plus 82 plus 94 plus x. So the average of those 5 numbers you want to equal 90. So if we multiply both sides by 5, so here's the initial expression, 88 plus 92 plus 8 plus 82 plus 94 plus x. That's the numerator, divided by 5 equals 90. So we can get rid of the denominator, multiply both sides by 5. So we multiply the left side by 5 and the right side by 5, and now we no longer have fractions or a denominator. That's not 1. We have 88 plus 92 plus 82 plus 94 plus x equals 450. And now x is going to equal simply 450 minus 88 minus 92 minus 82 minus 94. And x will equal 94. Alright, 70. Make a double box and whisker plot for the data. And we have A and B. We're not told what it means. We have no context. We have no idea why we're doing this, etc., etc. Okay. What you have to do is put A and B in ascending order. And so for A, you get 18, 18, 20, 22, 24, 26, 26, 26, 29, 31, 32, 35. And then for B, 16, 16, 16. There's 3 16s, a 17, a couple of 19s, a 20, 2 21s, a 22, a 25, and a 30. Okay, now there's 12 numbers in each series. Although you could make comparison box plots for 2 sets of numbers in which the number of numbers, the quantity in each set was not the same. That's okay. You can compare distributions. That's what you're doing with the box plot. You're comparing the 2 distributions. Anyhow, so we'll go. So each set has. Each one has 16 numbers. So we'll go to A. Here's 1, 2, 3. Each one has 12. 1, 2, 3, 4, 5, 6. So the 2 numbers in the middle are 26 and 26. 1, 2, 3, 4, 5, 6. So here's 6 to the left and 6 to the right. The 2 numbers in the middle are both 26. So the median is 26 plus 26 divided by 2, which is 26. Okay, now Q1, we got 6 numbers to the left. So Q1 is the first 25% of the numbers. So we go 1, 2, 3, and then 1, 2, 3. We divide the left side into two parts. We're taking a sub-median, if you will. So the two numbers in the middle of the left-hand side of the numbers, of the left-hand 6 numbers, are 20 and 22. 20 plus 22 divided by 2 is 21. So the first quartile, that is the number below which is the first 25% and above which is the other 75% of the distribution, is at 21. The median that splits the distribution into 50% below and 50% above that the median number, okay, is 26. And so now we'll go on and we'll go 1, 2, 3 on the right side, and then the next 3. We can see that 29 and 31 are the middle 2 numbers in the right-hand 6 numbers. We take the 2 numbers and add them together and divide by 2, and we get 30. So this is quartile 1, and this is quartile 3. To the right of quartile 3 is the top 25% of the distribution. To the left of quartile 3 is the lower 75% of the distribution. Okay, now let's do the same thing for B. Put it in order from lowest to the highest. 16, 16, 16, 17, 19, 19, 20, 21, 21, 22, 25, 30. Now it also has 12 numbers. The B set has 12 numbers. Now the median is going to be, the middle 2 numbers are 19 and 20. So 19 plus 20 divided by 2 is 19.5. And okay, so let's talk about the left, the first quartile. Okay, there's 6 numbers to the left. We take 16 plus 17 divided by 2. So Q1 is 16.5. This is the median, is 19.5. And Q3 will equal 21.5. Okay, now I made an x-axis that encloses the lower min and the upper max for the 2 distributions. Now you can have comparison box plots for 6 or 7 or 8, as many as you can find on one screen. You can do comparison box plots on one graph. Okay, so I go from 15 to 40 with this graph. All right, so let's start with A. Okay, so the min is 18 for A, okay, right here. And Q1 is 21, which is here. And the median is 26, which is here. And Q3 is at 30, and that's right here. Okay, and then the max is at 35. Min, Q1, median, Q3, max. Okay, so there's your box plot. All right, so that's A. And A, it looks fairly what we would call symmetrical. The pieces are more or less divided up evenly. Not quite, but anyway. Let's look at B. B is definitely not symmetrical. Okay, the min is 16. Now Q1 is 16.5. Okay, just half a point away from it. The median is at 19.5, which is right about here. And Q3 is at 21.5. And then 30 is the max. Okay, so this distribution looks what statisticians like, the term they like to use is called skewed. Okay, it's stretched out to the right. You have a few big numbers and then not too many smaller numbers. Okay, so that's the two box plots. They're labeled A and B. We have the x-axis, and we have the We have the 5 number summaries that's included on the box plot. Min, max, Q1, Q3, and median for both box plots. Okay. Now, just so you know, I will not put a comparison of two box plots that you construct by hand on the test. It simply takes too much time. But I will probably have you make one box plot by hand. All right. I'm going to pause for a second and then change the book over to the Chapter 1 review. Okay, continue with the Chapter 1 review of just simply Part 6 and 7. So you're asked to express each relation as a table, a graph, and a mapping, and then you're given a set of ordered pairs. Okay, so as a table, -1, 1, 0, -2, 3 and 1, 4, -1. So you draw a vertical line, X and Y, and then horizontal lines, as many as you need to for however many ordered pairs you have. Since there are 4 ordered pairs, then then you need 3 lines. Okay, for the graph, you're just using XY coordinates. So -1 up 1, 0 down 2, 3 to the right and up 1, and 4 to the right and down 1, and then label the points. Okay, in mapping, make a couple of ovals, call one domain, one range. Put in the domain numbers, -1, 0, 3, and 4. And then put in the numbers that they map to, 1, -1, 1 and 1. 1 and -1, I'm sorry. Okay, so 1 is in there twice. The domain is -1, 0, 3, 4. And the range is 1, -2, -1. Okay, 62. Okay, we're going to express it as a set of ordered pairs. Forgot the curly brackets. Okay. So curly bracket 5, 3, comma 3, comma -1, comma 1, comma 2. All of these in parentheses. Oh, so curly bracket, open parenthesis, 5, comma 3, close parenthesis, comma open parenthesis, 3, comma -1, close parenthesis, comma open parenthesis, 1, comma 2, close parenthesis, comma open parenthesis, -1, comma 0, close parenthesis, close curly bracket. Okay. 64, gardening. On average, 7 plants grow for every 10 seeds. So the rate at which plants mature from seeds is 0.7, or 7 over 10. If you want to use 7 over 10, that's fine, or 0.7. Either one is correct. Now, you don't have to make the rule here, the function rule, but it certainly helps. So you have some idea of what's going on. But if you did it with some other method, you made the table first, then you make the equation or whatever, it's all right. Anyway, so when you have 50 seeds, it'll be 0.7 times 50 is how many plants you're going to get on it. It's the expected amount. The expected amount is 35. If you plant 100 seeds, the estimated amount of plants you'll get is 70. If you plant 150 seeds, the estimated amount is 105. And if you plant 200 seeds, then the expected amount is 140. Okay, next page. Go to the top. All right. is this a function? Well, you have 5 points. 1, 2, 3, 4, 5. If you run a vertical line through each one of those 5 points, the vertical line does not touch any of the other points. Therefore, it is a function. You could make a rule for it. It looks like y equals, let's see, 2, 1, 2. This is, the equation looks like y equals x squared. Anyway, that's at 66, 68. If f of x equals 2x plus 4, find each value. Okay, f of negative 3. So f of negative 3 equals 2 times negative 3 plus 4, since f of x equals 2x plus 4. So that'll be negative 6 plus 4, negative 2. Um, 72. F of m plus 2. Plug in the m plus 2 where x is. 2 times, open parenthesis, m plus 2, close parenthesis, plus 4. 2m plus 4 plus 4. 2m plus a. 74. A teacher claims that the relationship between number of hours studied for a test and test score can be described by g of x, g being the name of the function, 45 plus 9x, where x is the input, where x represents the number of hours studied. We want to graph this function. Okay. The y-intercept is 45 and the slope is 9. Okay. If the student studies 0 hours, the predicted score is 45. For each hour the student studies, the predicted score increases by 9 points. Okay, so here are the hours. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, I'm going to start the graph off at, I'm just going to have a little gap here, then start at 45. And then I increase by 9s since that's the slope. Okay, so if it goes up 1 hour, then the grades on the point go up by 9. So this makes the slope look like y equals x squared. So in other words, it's not as steep as a slope of 9 ought to be. And that's because the scale on the x-axis does not match the scale on the y-axis. The difference is a ratio of 9 to 1. Okay? This scale, there's 9 numbers between 2 hash marks, and there's only one number between these. All right. But anyway, you can see that the scores reach 108 at the time that the student studies 7 hours. Okay, 7 times 9 is 63. Plus 45 is going to be 108. And I stopped the function here. So not because it's not like the student couldn't study more than 7 hours, but it's hard to conceive of how he could score or she could score higher than 108. So the domain, even though you're not asked, it would be a good question to ask, well, what's the domain? Well, you can study 0 hours, but you can't study less than 0. So if I was going to say the domain, I would say the domain is all real numbers such that x is greater than or equal to 0. Now, I won't expect this on the test, but I'm just putting this in. We'll be talking about this later on. And less than or equal to 7. But if I asked you to name the domain, I'd ask you to say, you'd say something like x is greater than 0, but less than 7. This would be a good. This would be an extra credit question. Okay, you tell me the domain and range on a word problem like this. Okay, now what's the range? Well, according to this model, you can't get a 0 on the test. Okay, if you don't study at all, you don't get a 0. The lowest you can get is a 45. So the range, g of x, or y if you want, g of x is greater than or equal to 45, less than or equal to 100 and what do we say? 108. Okay, so that's the domain and that's the range. And that is it, I believe, for the review. Okay.